In this tutorial, I'm going to demonstrate how to apply source transformation to simply solve for voltages and currents in fairly complicated circuits. So let me just quickly review the idea of source transformation, which is demonstrated down here. A voltage source in series with a resistor between A and B can be thought of and is equivalent to a current source in parallel with the same resistor, as long as the sources are scaled so that Vs is equal to Is, Rs. Notice, for example, as a quick comparison, what is the voltage here on open circuit? It's Vs. What is the voltage here? It's also Vs. Let's apply source transformation to our two-loop circuit. So in this case, we have two sources. We have this source up here, and we have this source over here. And I want to try to simplify this circuit by applying transformations to those devices. And this is the approach I'm going to take. I'm going to notice that these devices on the bottom, 8 volts, 1 ohm, and 4 ohms, are in series, and so they actually look a lot like this voltage source in series with a resistor. And the same pattern occurs at the top. I have a voltage source in series with resistance, and I can apply source transformation to those devices. Okay. Now what I'm going to do is just relabel the circuit points, because I'm going to redraw the circuit to solve for this key current here. I'll call this current I. I want to solve for I. So let's start by, this is going to be a little bit more readable if I do this resistor vertically. So that current is now flowing down. That resistor is 2 ohms. And the rest of the circuit can be completed like this. Think of taking this circuit and turning it 90 degrees. That means that point 4 is up here, circuit point 3 is over here, circuit point 1 is here, and circuit point 2 is up here. Now, continuing on, what I'm going to do is apply source transformation on this half of the circuit. And I'm going to apply source transformation over here to this half of the circuit. Now, let's do the green part first. I'm going to do the green part. We have 1 plus 3 in series, forming a 4 ohm resistor over here. And we have the current Is. The voltage source is 14. The resistor is 4. 14 fourths is 3.5. So this current is 3.5. The current is positive because the arrow is going in the same direction as the minus to plus symbol. The direction of the arrow follows the direction of the plus. Going to the other side, the red side, we have a total resistance 1 plus 4 equals 5, and the current source, the second current source over here, is in magnitude 8 over 5, which is 1.6. But notice that the plus is going towards the 3, which means that this current is actually minus 1.6, going towards the 4. Alright, now we have a fairly simple circuit that we can deal with. We have one node at the top and one node at the bottom. Everything in the circuit is parallel, so I can do some simplifications And I'll do this simplified circuit in orange. We have two current sources that can be combined into a single current source of 1.9 amps using circuit equivalencies. The two resistors 4 in parallel with 5 become a 29th ohm resistor. And finally, the piece of the circuit that we've left alone this whole time is the 2 ohm resistor, and that current remains I. So now we can use current division to solve for I. I is 29ths of 29ths plus 2, that fraction of the current, 1.9. Simplifying, we get 29ths over 20 plus 18 ninths times 1.9 which simplifies to 20 over 38 times 1.9, which in fact is 38 over 38, or exactly 1 amp. So we've successfully solved for I, which means now we can go back to the original circuit, and that current is 1. The rest of these markings will be from the knowledge we learned. So I have V is equal to IR. That voltage will be 2. That means that that voltage is 10 volts, 8 plus 2. That means that that current must be 2 amps, leaving that being 8 volts and 2 volts. Going up here, applying KCL, that current must be 3 amps, which means that that voltage is 9. And the current's flowing in the other direction, so that voltage is minus 3. That's source transformation.